Hello, everybody. My name is Ian Smith from MIPI Alliance, and I'd like to introduce you to today's webinar, A Beginner's Guide to MIPI Debug Solutions. Our main presenter today will be Enrico Carreri from Intel Corporation, and Enrico is also chair of the MIPI Debug Working Group. Just a little bit of housekeeping before we get started. Firstly, you can see we have a Q&A box. We will be running a Q&A session at the end of Enrico's presentation, so I'd like to invite you to submit your questions into the Q&A box as we go along, and we'll do our best to cover all of your questions later on in the webinar. Obviously, if you have any issues, please you can chat to me as we go. Any technical issues, please let me know. Otherwise, I think it's time to really get into the main presentation and get started. Let's look at our detailed agenda. First up, Peter Leskin, who's the Managing Director of MIPI Alliance, will give a quick introduction to the MIPI Alliance and give an introduction to the organization, its aims and goals. We'll then hand over to Enrico to go through the main part of the agenda. First of all, covering the MIPI Debug Working Group, covering its focus and goals, giving a little bit of detail about the approach of the group's work towards its specifications, and then into the main body of the presentation covering the debug system and solution stack, giving an overview of the available debug specifications, and then summing up with a conclusion. Okay, so without further ado, we shall hand over to Peter to give a little introduction to MIPI Alliance. Over to you, Peter.
Great, thanks, Ian, and welcome everybody, and thanks to Enrico for his time today to deliver the webinar. I'd like to just give you an introduction to MIPI Alliance. I think many of you probably are well aware of it, but I want to give a little bit of context to Enrico's presentation and give you a sense of where debug fits in as well. MIPI Alliance has been in existence for a while now, really at the inception of the camera phone in 2003. Really the primary purpose and sort of foundation of MIPI's formation was the integration of cameras into mobile phones, as well as more robust displays as well. So fast forward from 2003 to 2020, it's certainly been a monumental breakthroughs for the mobile industry. Mobile has been influencing a number of different industries as well, which I'll talk about in a second. But today, 2021, we should probably change that date on that slide. But there's over 50 specifications covering a range of interface application needs for mobile devices. And there's at least, we're comfortable to say there's at least one MIPI specification in every smartphone on the market today. And the real foundation for MIPI, the organization, started with the device OEMs and the semiconductor companies who saw the need and really kind of disparate and also proprietary implementations of that interface between the camera and the processor. And over time, camera specification was developed, our physical layers were developed as well, and the ecosystem has grown to over 350 members, over 29 countries, to include a wide range of players in the mobile and other industries that leverage mobile specifications, including test equipment companies, the test labs, software providers. IP and VIP providers are very important and have grown in importance over the years. Range of consumer electronics companies. I get surprised almost every day, every week for sure, the different types of applications where I see MIPI specifications. And then automotive OEMs and tier one suppliers, and we have a number of different webinars that have focused on automotive recently as well. Just to give you a flavor, this really represents actually only a third of the MIPI members, but the contributor and board members are those who actively work to develop the specifications on a day in, day out basis. I don't think there's a day in the week where there's not a MIPI teleconference. I think we have difficulty these days trying to find time to fit teleconferences in with the level of activity within the organization. But again, you'll see some familiar names. And if you go out to the membership list on the MIPI website, you'll see another 2/3 companies who support MIPI specifications and have access and license to the specifications, but don't participate in the day-to-day activities. As I indicated, this is really just the mobile system diagram. Debug is an important component. We actually have separate system diagrams for debug, which I'm not sure if Enrico will go into, but I'm sure he'll get into a better background, and I'll leave it to him to go through. But you'll see that this really represents the wide range of MIPI specifications within mobile devices. You'll see the different industry segments that MIPI supports, and obviously mobile is the foundation and the centerpiece, but automotive, industrial, consumer electronics and heads-up displays, the aviation industry and the medical device industry, as well as IoT, are all embracing MIPI specifications. The last comment that I'll make is, MIPI specifications and usage rights are granted to the members on a royalty-free basis for implementation in any application, any type of implementation. So that's unique to MIPI. I think the royalty-free aspect of MIPI and mobile very early on in 2003 was one of the fundamental success factors, we believe, for the proliferation of cameras and increased functionality and displays in the mobile phone. So with that, let me turn it over to Enrico. Enrico's a principal engineer with Intel Corporation and chair of the MIPI Debug Working Group, and an all-around good guy as well. So with that, I'll introduce Enrico to present a beginner's guide to MIPI debug solutions. Thanks, Enrico.
Well, thank you, Peter. Appreciate it. So welcome. And today I will give you a little bit of a taste of what the debug workgroup is doing and the specifications that hopefully can help in your implementations. So let's first talk a little bit about what the debug workgroup does, what our focus is. And we're really focused on working and to unify various different pieces, as you can see here in the slide. We're focused on different protocols for both debug communication, if you want to set some registers or status information and things like that, and trace. And you would think, hey, I'm in a lab environment, I'm doing debug, but we also focus on what's listed here as that highly integrated fielded system. So we also take in mind when that system is out in the field, when there's users using it and when they're experiencing things, what kind of debug can be done in those environments as well. So it's not the open bench, I can only do debug there, but it's beyond that. And we have those considerations, and you'll see how our specifications help in those areas. And usually when people think some things on debug, and kind of where I was kind of going a little bit with is, the hardware, the system, but it's more. It's really, we also think about the software layers, and we look at the protocols and getting these things out in a complete system, in that fielded system. So it's really, and you'll see, it's across the solution stack and what we're thinking and what we're providing. As I mentioned, we have not just those registers, your information registers, trace and things, but it's really the configuration and control of that. So if you have, let's say, a trace system, it's a way to get in and control that system and maybe filter out things and such. So we also focus on that. As I mentioned, when we talk about the fielded systems and things, if I have my cell phone or other device, when it's in the field, you don't have these debug connectors coming out and things like that. It's really in what we refer to as maybe the closed case or the closed chassis. And there, we need to look at how to reuse the interfaces that exist. So again, if I have my cell phone as an example, I want to be able to reuse that, that little USB connection and make sure that that is reusable for debug. So we look at reuse of those kinds of things and the protocols that go across those as well. Now, yes, I've talked about those fielded systems, but yes, we still do those bench tops and things like that. So there's still the various different connectors and things like that that we look at and help implementers with, and the various pin assignments for those connectors, or even multiplexing on top of existing ones. And then finally here, we look at the electrical characteristics. So we have a few pin interfaces defined. So we also look at those kinds of things. So there's a lot of pieces that the work group thinks through and thinks about and looks at. And really, we're looking to find ways to really, as it says here, kind of unify and bring these together. Now, why all of that, right? Why? So the goals. So really, for debug, right? No one wants to pay for debug, right? Right. So one of the big things that we try to do here, and part of having these kinds of specifications, is really to drive down the development and implementation costs, right? Cost of usage, right? Trying to drive those down. That we believe that that's a big value. The other thing that we're trying to do as well is, if you look at the system, a system that you have, right, that system usually isn't all homogeneous. It's not all from one vendor, right? There's lots of different vendors. Some have the bigger pieces, some have the smaller. There's multiple vendors. So having those specifications really helps with interoperability. If you're doing debug and you have a set of tools or have a set of interfaces and whatnot, having them being able to communicate with each other and communicate with your maybe standard tooling or common tooling is quite important. And again, it goes back to that driving the cost. What you don't really want is this one chip having a particular specific tool with a specific interface, and another chip has their own, and so on, right? That's a lot of cost. And we're trying to drive that down by having each one have the same interface or same protocols or whatnot. And we'll talk about how that scales and how we do that. We also want to define kind of those different interfaces. Again, that's where we get that interoperability. So providing not just the hardware, the physical interface, but even the software interfaces, so that, again, we reach that whole stack and supporting that system-wide debug. And last here on enabling is to leverage what's there. Again, no one wants to pay extra for debug, and that's always an added cost, right? So leveraging interfaces and things like that are existing, it can be very, very important. Again, going back to cost, right? And again, we're focused on those fielded systems where you do have limited interfaces and you want to reuse. So that's what we're trying. That's what we want to enable. That's what we want to help. When we're doing this and when we're thinking about this, it's not just the person sitting in the lab trying to get a product out, right? It's across the whole lifetime of the product, right? All the way from the manufacturing through to the end user. So we're really looking to supply, as it says here, supply benefits. And as part of the working group, and what we do is we're looking at gaps in that system debug story and to see where we can provide value and help. We look at the gaps not just within our structure and within our architecture inside of MIPI, but even just in general, what the market is lacking. And so we look at those, and that's what kind of drives what the what the workgroup does and the types of specs that we have. And beyond just the specifications, we also help try to develop recommendations, white papers, and things like that, because to help with adoption, right? And again, that's where some of the power comes into play of having those specifications and really getting more and more of that system together to reuse. As it mentions here at the bottom, we don't work in a vacuum, right? Our debug workgroup doesn't. We work with others, and a great example of this is when one of our latest specs was the debug for I3C, where we utilized the I3C interface as a debug interface. Here we worked a lot with our internal MIPI working group with I3C, and we did that and we worked together, and that's where we get those benefits. Again, leveraging things that are existing. And we also do that outside. You'll see some of the specifications we work with USB and other types of interfaces. So the working group does do that. Again, it's all about leveraging, driving the cost down, and such. Okay. So now hopefully it gives you a good idea of what the work group, what we're doing, and and you'll see how all the things that I just talked about really comes into how our specs are developed. So let's talk about how we do this and what I like calling the layered approach to our specifications. And so again, when we look at that system level, right, and how we're going to debug that system or end product, the specifications are really done across all of the different, across that solution space, and up and down the stack and across the different subsystems. And we'll see that. I have some diagrams to show how that does and how our specifications get those. And it's really together, putting all the specifications is really to help provide that cohesive solution. So you'll see how we've done that and how we're trying to provide that. Now, there's a lot of different pieces to that solution, and all the pieces that we're going to talk about today, you don't necessarily need to implement them all. It's not an all or nothing kind of implementation here. You can pick and choose what you need for your situation. And what's nice is they're somewhat targeted for certain pieces of the layer, and if that's what's necessary, you can do that. Some products may not be able to implement everything at one time. You can add on to that layer later. And so we have that strategy, that approach to our specifications. You may already have something and you want to add or improve to what you have. You can do that. That's how these specifications work. And again, like I said, it's not an all or nothing. You can pick and choose, piece together what you need for your particular situation. Again, as it says here, we do focus on different layers, and we're going to get into that and how how we do that. Okay. So the framework that we have, and we call it a framework, it's the set of all of the different specifications that we have. We break it down into different subsystems. That is where we have a particular focus within the system, right? So a particular spec will fit into one of these kind of 4 subsystems, and that's part of that layering, part of that. You could think of it as maybe Lego blocks to put together for that full system framework. And the four are listed here. We're going to get into in more detail. But first is the access and control. So how do you get in, do something, set registers and things like that. There's the instrumentation and visibility, the protocols, how do you get that data out, how do you see things. And then there's the 2 on the interfaces. There's the physical debug interfaces that we've defined, and what we've called these network interfaces, where we can reutilize interfaces, protocols, not protocols, but transport layers, and reuse those and put our various protocols on. So we'll step through that. Now, to relate this a little bit, this may be a little busy here, but this is our what we call our framework diagram. And if you look at any of our specifications or white papers, you'll see this diagram. And what it's representing is just kind of a generic system. And you can see, if you look at it, at the bottom of the system is what we call the debug and test system, or the DTS. And that is, think of it as your debug tool, the thing that you're using. Some people call it the debug host, the debug tooling. We call it the DTS. And that's the person sitting on its system trying to debug the target. And so the rest of the pieces are part of the target. And you start from the bottom, you have your connectors to the board, your pin interfaces, the link, the PHY layer, the link layer, and so on, all the way up to that system application layer that's shown at the top. And you have, and we use this kind of color code, if you look over at the legend, the color code of those different groupings that we had, subsystems that we had. So you can see the different network interfaces at the bottom. You can see some of the other groups that we have. So, and we'll go through each of those different colors and talk about the specifications that go with those in a moment. But hopefully this gives you an idea that if you look at this whole system together, we've hit all of the different pieces here from a debug perspective. And again, this comes back to, if you need maybe only the green piece, well, go to the specs that are related to that. If you only need maybe a connector, let's go to maybe, one of the blue specs or whatnot. And so we'll talk again. We'll go through each of these colors, each of these subsystems, and what specifications you have. Okay. Now, a different way to look at that is through the system stack perspective. Now, this is kind of you might have seen this in other ways, the different solution stack from like a link layer, transport layer, and so on, up to the application layer, right? That's a common software kind of model. But we look at it the same way. And this diagram here, we call it the butterfly diagram because it's equal on both sides. And this represents the different layers in that DTS, that debug and test system, and the target system that you're debugging. And there's a couple different things about this diagram. One is, you see it's equal on both sides. So there's an equal piece that correlates together. And that's important because for us, we deal with each of those layers from a specification perspective. And what's really powerful here is we're able to swap out certain layers due to the need that you have. So let's take an example. An interesting example. So what you can do is, let's say you have maybe a trace, right? And so at the infrastructure driver level, you have some type of trace aggregation system, right? So let's look at it from the target system for a second. So you have maybe some hardware that aggregates everything together. So your debug function is all the things that are collecting trace, you bring it in. Now, let's say my company has multiple different types of parts. Maybe I have a small part, maybe I have a big part. And because of that, my link layer, the available links that I have may be different. So here, because I can split out that maybe infrastructure layer versus the link layer, I can scale this. So with the same infrastructure, or with the same MIPI specification here at the infrastructure level, I can reutilize those upper layers and change the bottom. So I can have, maybe for that smaller device, use I3C. And maybe for the larger device, I may use USB or our network, or like an Ethernet, TCP/IP or something, or what. And I can change that, and they interact together. So I don't have to change those upper layers after that infrastructure and debug function. I don't have to change that. I just have to change my network layer and link layer. And our specifications allow you to do that. So if you spend time and energy, money on building that infrastructure, and on the other side, all of the software, you don't have to throw that away. You can reuse it. And that's part of the power here and in the flexibility of how the specifications are done. And that's, again, very important, goes back to that cost, keeping the cost low and reuse. And that's really nice, especially if I'm building applications in this example here. If I'm building some maybe trace viewer, the trace viewer doesn't care what the link is. It doesn't care if I got the trace data through, in this case, back to the example, I3C or USB. It doesn't matter, right? It doesn't see that at that layer, right? There's an abstraction eventually to the layer. And that's very powerful because, again, if I have those two parts, the small and the big, right, that same application, that same driver, in most cases, would work across both of them. And that's very, very useful. And again, back to the cost and total cost of ownership. Okay. So when we're talking about the specifications, think about these two diagrams, right? The system diagram, which we'll see over and over again, but where those pieces fit within the system, and think about where in that stack does it actually work as well. Okay, so again, that's kind of the architecture maybe of our specifications. So talked a lot about setting this up, how all the pieces go. So now let's actually talk about what we have to provide. And so when we do that, we're going to look at each subgroup or subsystem, and we'll go through that. So the first one, if we start at the bottom of that subsystem diagram, that framework diagram, is the physical interfaces, or what we call the DPIs, the debug physical interfaces. And really, this is at that boundary between the debug and test system and really the SoC. So it's right there, and the connections done there. And you can see what we'll see as we go through. I've kind of highlighted in red here where in that system diagram we're focused on. You'll see as we continue, we'll move through this. In here, we have a couple different sets of specifications. The first two here are, they kind of complement each other. These are for trace. So we have on the top here is the parallel trace interface, or what we call PTI. And at the bottom is the high-speed trace interface, HTI. And from a high level, they do the same thing, right? They're pulling out trace data so that you can connect and get all of the data that you need. But they're done in different ways, and it depends on your usage and what you need. So parallel trace is having obviously a wider interface, a simpler interface to get that data. It's what we call kind of that bare metal. You attach and you get the protocol directly out. Typically, it's your simpler CMOS general purpose I/O kind of connectivity. And to get the bandwidth you need, you change the width. It's showing here a width of 4, but the specification allows wider. And so you get, again, more bandwidth through wider. And you can scale that based on what you're able to do on your system. Now, high-speed trace is serial, right? We could have called it the serial. But the serial method, where you're utilizing those high-speed serial interfaces, those high-speed serial PHYs that you have, and you can see here some of the different PHYs that can be used by it. The PCI Express, USB, any of the kind of displays like DisplayPort, HDMI. And now we utilize those PHYs to get the data out. So slightly different, right? Again, scalability of your product. If you don't have those high-speed PHYs, then PTI is probably your choice. And then the opposite, if you have those high-speed PHYs, maybe you do want to then utilize HTI. So they kind of, like I said, they kind of complement a little bit of each other, and it depends on your usage. And again, what these are to do is pulling out amounts of trace data. Again, it could be quite large if you do something like a high speed, but it can be pretty good with PTI as well, depending again on the size. Okay. We also have what we call the debug connector recommendations paper, where here you have a lot of different things, a lot of different connections, maybe PTI, maybe JTAG, which we'll talk a little bit about in a moment, or I3C, which we'll also talk about in a moment, where you need maybe a board header or something like that on your system to connect to. We have some different recommendations for that, how we do that, to have some common connectors. I show a couple here on how they may look. But we define those different pin interfaces and how to have that common use of those types of mappings. And there, you'll see in that white paper, they're mapped to very common debug scenarios. So you can have, maybe as I alluded to earlier, maybe trace and control together, and how you would get that on maybe a 10-pin connector or a 20-pin connector or whatnot. We have that there, and that's what that document helps. And the last one here, at least in the DPI specifications, is what we call NIDINT, or the narrow interface for debug and test. And what NIDINT actually does is it shows how to multiplex debug protocols, debug usages on top of functional interfaces. And you can see here, as a good example, we show how to reuse something like a USB Type-C connector, and how we can use maybe an alternate node that we've defined, and how to reuse those pins for your trace or your connection or your debug communication or whatnot. So we've defined things like that, and there's several different. I mentioned USB Type-C. That's kind of a popular one now, but we have others in there depending on your form factor and such. But it goes back to that principle of reusing what's existing, especially in those closed case, closed chassis environments in the field. And so that's what the specification is to help, is to define those common multiplexings and common ways to control those multiplexings based on, as I gave an example with USB Type-C, of using alternate nodes. We've defined that alternate node, or whatever the interface may be, how to do that. And that's what that specification does. Okay. So now moving into the system a little bit more, are these debug access and control systems. So these are the paths to getting to maybe registers or memory. This is kind of what I was calling debug communication, right? Getting some configurations and getting some status registers and things like that. That's inside the system. Okay. So we have two for this. One isn't necessarily a MIPI specification, but the MIPI, we did a lot of the work coming out of our work group and pushed that to IEEE. But it's where, again, back to the cost, is really trying to drive down smaller interfaces. The IEEE 1149.7, one of the interesting things there was their minimal pin interface. We call it MinPin, our MinPin interface. And if you're familiar with that spec, it defines this two-pin interface, TCKC and TMSC, to go in and utilize your basic JTAG function, or your JTAG functionality, getting to tap controls and whatnot. Again, that's back to those two pins, and you'll see how that's very useful if you go back to the previous slides on some of that debug connector and how to get smaller connectors and things like that. You see how those kind of work together. The other one is our sneak peek protocol. So it's a protocol that we use to do that debug communication. And you can see in this diagram, the diagrams here, it's a packetized protocol to get to different registers and these various different behaviors. So it's a protocol layer that we will talk about how that goes on top of other interfaces, other link layers a little bit later. And we use that to do, again, register interfaces. We call them access spaces, access to the various capabilities and such. There's a state machine that handles all of the standardized communication back and forth and such. So that's kind of our main protocol for debug communication. Okay, and you can think of it, and now if we're going to do it as a little bit of a comparison here, you can think of it as, packetized versus with 1149.7 JTAG-TAP, that's more maybe bit banging. So there's a slight difference here with that, and what Sneak Peek provides you and the next one is our debug instrumentation and visibility. So these are ways to communicate and store the various data from things like your trace systems and such. Okay, you can see how that gets into all the various trace and now how we get up into the software layers. Again, they are very similar. We have for our trace protocols, we have system trace protocol, STP, and we also have the trace wrapper protocol, TWP. And you can see here, somewhat similar. They do both bring out trace data and ways to see trace data. One, the system trace protocol, STP, is more packetized. It's a base protocol that brings out the information in kind of the streaming form, versus the trace wrapper protocol is more framed, and it brings it out a little differently in this case, and it has these various blocks that come out. But again, these define ways for that trace information from your trace aggregation out. Again, a common way, and very similar to, as I mentioned with Sneak Peek. You can look at this again as the protocol that's going to go on top of the various different link layers. And you can have that common protocol shown of one of these here that you can do that. And we'll talk in a moment about that. We also have gigabit trace, which kind of goes a little bit with what we talked about before, but how we do that as a networked stream of data and putting those things together. Then at the layer above this is the system software trace, or what we call SysT. And here is a OS-independent protocol that you can use and have implementations in your embedded software. So you can have SysT that then goes into the next layer, which is from the previous slide into one of those protocols, and then into a transport, which we'll get into in a moment. And you can see, again, that layering of it. Here with SysT, again, OS independent, you have an implementation library as part of, as it shows here, a part of a client. Maybe it's part of firmware. Maybe it's part of an application layer. As an example, the SysT library implementation is part of the Linux kernel, as a good example, and can be used. And so that's kind of how we do it. And as it shows in the diagram, again, those messages then go down to the next layer and so on. And then the last subsystem we have is the network interfaces. And I've kind of alluded to these things where we take those protocols that we've talked about, maybe TWP for trace and Sneak Peek, and then transport those across one of these network interfaces. So we have those different things, and you can see here, it does mention the sneak peek gigabit trace, and we bring those across some existing ones that we have. So when we look at that, we have two different specifications. We have our gigabit debug family that we call, and this defines how we take sneak peek and TWP, our trace protocols, and send those across and map them to, in this case here, USB is one of them, and Internet Protocol sockets, so TCP, UDP. So we define how that mapping is done. So again, let's take sneak peek, for example. How does a sneak peek protocol, how does that map on top of USB? And how do we define the different endpoints and things for that to work? And that's done in that gigabit debug spec. And again, similarly, we do that for TCP UDP in our Internet Protocol sockets specification. We did this again, same thing with debug for I3C. So if you look at it here, we've defined how to use it over USB, TCP, UDP, and I3C. We couldn't call I3C gigabit debug, obviously, because of its speed. So that's why it's kind of separated. But we've also defined how to use sneak peek, how to use trace, and other protocols across that I3C. And the idea with the I3C a little bit more is, remember I mentioned min pin, or that minimal pin. This is a more, if I compared it to JTAG, right, that 1149.7 that we mentioned, I3C has that same 2-pin interface, but it gives you more functionality and gives you better reuse of sneak peek protocol or TWP and whatnot, and it gives you that similar effect that we did with the gigabit debug. Just a little commercial. We are having an upcoming webinar to dive a little deeper if you're more interested in this newer technology with I3C. We're doing a deep dive into how that works even further. So please attend that webinar for more information there. So that hopefully gives you a good idea of what specs we have, how we use them, how they go together. Hopefully, I've explained to you how they fit across the stack, how they can layer, how they fit together, and give you that system debug perspective. And hopefully, you can see by having all of that, we can reduce the effort, the cost, maximize the reuse, and switch in different pieces of that stack. And hopefully, as I've walked through it, maybe you're starting to see, hey, this is a piece that I can use, or that's a piece I can use, and see that. Again, as in some of the examples I gave, these specifications together can scale. As it says here, simple ASICs, simple designs, up to those complex SoCs, right? If you need more bandwidth, you go to those higher interfaces, but I can still do sneak peek as an example, right? We should be able to do that. Single to multi-function, I can do trace, I can do debug, I can do debug communications, I can do multiple ones, I can have a set of trace and things like that. So I should be able to do that. And again, top to bottom, we have the various different pieces of the solution. We have things at the pin level, we have things at inside, we have things at the top level. We have them throughout. And again, lastly, use as you will. You could take pieces here and there to really put together the whole solution that you need. So hopefully you have a better idea. There's lots of information. A lot of the things that I talked about today is part of that overview for debug. So you'll see a lot of similar diagrams and explanations there. That'll give you a lot of good background, more background than I gave, more background and links to a lot of our information if you're interested in a particular specification. Our specifications are publicly available to look at. and the link is there and such. So with that, I thank you for your time, and let's move to questions.
Yeah, thanks, Enrico. That was a fantastic presentation. Lots of detail there. You covered a lot of ground, so thank you very much for putting this presentation together today. We do have a number of questions coming in through the console, so I think it's probably time to get started, to get through as many of those as we can. But let me just take them from the top here. First question we have is, what will I need to get started with MIPI Debug? I'm guessing this means in terms of perhaps the hardware and software tools.
Yeah, so what I would suggest, I think the best thing to start with is really coming back to the overview document and really figure out what you need, right? As I said, these can go with different pieces. So you need to, I would suggest figuring out what do you have that you want to hold on to, and what are the gaps that you need to fill that we can help. And go from there. Once you figure it out, let's say you have kind of a solution, but you want to move to maybe a higher interface, maybe, or a better interface. I'll use a good example, just since it's newer on our list. I mentioned JTAG and I3C. So maybe you're using JTAG today, but you want something more powerful, that gives you more features, more feature rich, like I3C. Well, then I would suggest looking at that and saying, okay, well, let's move to the next step of let's look at that specification and figure out. Now, as far as what hardware, what software, it's going to depend. You know, the specifications are out there. As a MIPI member, you're able to go ahead and build those kinds of things. Talk to your IP vendor for more help there. Talk to your tooling vendors. Some of them are familiar with MIPI and our specifications and support the protocols and things that we've done. Talk to your vendors. Again, encourage those vendors if they're not as familiar to do the same. But that's kind of how I would look at it, is start with the specifications, figure out how you do, and then talk to your vendors and see what is available to you, and then figure out what where you want to go from there.
Okay, thanks, Enrico. So the next question actually fits quite neatly with the first one. Someone saying that they already have a partial debug solution. I'm just wondering how easy it is to add the MIPI components, and how nicely do the MIPI components fit with existing solutions? Is it an easy thing to integrate?
Yeah, I mean, I don't know if I would say it's easy. Anything that we do is usually a little difficult, but I think I like using the term straightforward. There are ways to integrate. So, for example, I'll just use an example of let's use Nidant as a good example, because that one I think is on the easier side as an example. But let's say you're looking for, let's say you have debug interfaces already, but you're needing a solution to get those interfaces in a closed case, in a closed chassis. And maybe you have, again, I'll just use the cell phone example, and maybe you only have your Type-C connector, and you're like, well, how do I use that? Well, Nidant will help you. Nidant will show and explain how you could get, let's say, JTAG out on that Type-C connector, as an example, right? How to get maybe PTI or HTI out on those things. It explains how to do that, and then, like I mentioned, how do you control it, right? Because if it's on my cell phone, well, I'm using that for charging, I may be using it for my headphones, I may be using it for other things. How do I get it to work for debug? It shows how to do that. So that's one way of utilizing the things that you already have, and then just getting that addition, right? A similar thing maybe with trace. Maybe you have all this trace coming into an aggregator, and now you're like, well, how do I better aggregate this so that my tooling can pick apart these things? Again, if I look at like maybe TWP, maybe I do the different framing. Maybe I use STP to get and use the major channels that have things in there. you can do those kinds of things. Hopefully that helps. Hopefully that gives a little bit of explanation of how I would look at those kinds of things. Those are kind of two different examples. But you can see how I could just take one problem maybe and utilize what we have from MIPI to help there.
Okay, thank you, Enrico. The next question is a quite specific question. Participant asking if sneak peek protocol can be used over USB 3.
Absolutely, 100% yes. And what I would suggest there, as I mentioned before, the gigabit debug specification, gigabit debug for USB, actually tells you exactly how to do that. So that will tell you exactly how to use sneak peek over USB. It goes into what you need to do with the descriptors and how the things are framed. It's all in there. Go right there, start right there.
Great. That sounds like the perfect answer to that question. Okay, next one. How does MIPI debug impact the system's performance of a real-time process? Here they're thinking about a measurement and control system. Is debug recommended for such applications?
That's an interesting question. It depends. I mean, I think it's going to depend on implementation, and depends what you're using, right? So if I do something like Nidant, for example, well, and let's say I was using it with my cell phone, right? And again, back to that example, I have Type-C, I'm going to get it in there. And let's say I'm doing some real-time, I don't know, telemetry trace or whatnot, pulling that information out, right? So it depends on how you get the data to that Type-C connection, right? And it's assuming that you're not using that Type-C connection as part of what you're debugging or getting your telemetry data on. So you can see it really depends on what you're doing and how it's implemented. Another example is trace, right? You could, if you build a separate infrastructure for your trace and how you aggregate that data, then it shouldn't hit your performance. But if you reuse maybe a non-debug fabric that you're using for some other reason to be part of your trace, well, yeah, then you're going to impact, right? So some of it is depending on how you utilize the specification. Keep in mind, things like sneak peek or TWP, STP, they're protocols. It doesn't tell you what specifically to implement them in, right? It's up to you. These are protocols. So it really depends. Now, let's say, for example, I use gigabit debug for USB, and I'm using, again, now I'm using it differently. I'm not doing Nidant, I'm doing USB over that functional USB. Now, if I was doing gigabit debug for USB, where I'm using the in-band USB, yeah, depends. If I have a separate USB connection and say, oh, okay, I'm using that, maybe that doesn't necessarily hit your system performance. But again, back to my cell phone, if I'm using it and that's the only one it has, and I may be doing something else, it does. So I guess, long story short, it depends on how you implement that, and you have to be careful, again, how you utilize those specifications. Again, you can keep it. Our specs can be done in ways where it doesn't, and in others not. So hopefully that helped to explain. It's not really a specific direct answer to that, because again, it's up to your implementation. Okay.
Yeah, clear answer, Enrico. So next question we have is a question asking about availability. Is there product IP out there in the marketplace?
So certain things it's going to depend. I'll be honest with you. It's not something we keep track of. Like I said, we know there are tooling vendors that utilize things. So again, talk to your tooling vendor to see if they support that. You could probably guess some of the tooling vendors by looking at our members page and seeing what tooling vendors are listed there. And same thing with the vendors. It depends. Now, I would say you're probably going to have more luck with tooling vendors than you will on like IP providers, because if I look at certain things, let's look at maybe how you would implement SneakPeek, right? It's going to depend. I mean, you could have SneakPeek could be done in several different ways, and you may choose a particular way to do it based on what you have. And so it's somewhat more custom to what you're doing. So for example, if you remember that diagram, there's different access spaces. Well, your access spaces may be unique to your product. Maybe you have an access space that goes to a certain controller or a certain subsystem. But that subsystem may be different for another vendor, or not another vendor, but for another product, or maybe some other company has it different. So mileage may vary in those kinds of things. Again, I think you'll see more on tooling with the protocols, and I think that's where you get a bigger benefit, and maybe not so much on saying, hey, there's this specific engine for something. So again, talk with your vendors. We don't keep track of those things, and encourage them. The information here, they can look at it and see if it's worthwhile, and so on.
Okay, thanks, Enrico. So last couple of questions here. Specific question, do you have any suggestions on I3C master verification setup?
I do not. I do know that we have done, if you look at some of the things that the I3C working group has done, they've worked with many vendors and such, and they've had interoperability events and things like that. I think there's a CTS, conformance test suite, that helps with those kinds of things. I would look at those resources. From a debug perspective, we use I3C as a fundamental piece for debug. So we do debug specific things as part of the allowances given by the I3C specification. But as far as the behavior of the master, electricals, and things like that, we utilize what the I3C specification and what the I3C workgroup has given. So I would consult that material. Like I said, there's been a lot of material there, a lot of different white papers and such, and I would start with that and go there. Like I said, we don't normally do that because, again, we leverage, as I mentioned before, we try to leverage all of that. From what was done for just basic for the general I3C community.
Okay, thanks, Enrico. So I think we're down to our last question. So if anyone's sitting on any questions out there, please submit them as soon as possible before we close the webinar. The last question we have here is there is speculation that mobile devices may do away with physical ports and go 100% wireless. If this happens, how do the MIPI debug specs support in-field debug?
Great question. Really good question. That's where the gigabit debug for IPS, or Internet Protocol sockets, come into play. So again, we can utilize TCP, UDP, and you can do them over your networks. So you could do them over your wireless network if you so choose. So that's how we're looking at it. That it's there. We have the way to send that as part of the TCP or UDP protocol, and it's left to then, again, scalability. You can choose what that network interface is. If it's your choice, right? Ethernet, Wi-Fi, 5, 6, whatever, right? And then that's how right now, that's the way we're looking at it until there's a different new wireless interface out there that we see value in. that's what we're doing. Just as a side, if you're a contributing member and there is a gap that you think there is that the gigabit debug for IPS doesn't fill, that we believe it does, but maybe it doesn't, let us know. That could be a gap that we can go fill. But right now, that's how we look at the wireless, is through the gigabit debug for IPS.
Okay. So one last question has come in, late question. Does MIPI provide IP, i.e. RTL, for some of these debug and trace features? An example would be an I3C to JTAG adapter that could be dropped into an SoC design.
So today, MIPI does not provide that directly. Like I mentioned, you need to talk with your various IP vendors to see what they have. But from a MIPI perspective, we currently do not provide anything that that people can go and download or whatnot or sign up for. Now, we are looking at providing potentially white papers to explain how to do that. But as far as like RTL codes that you could get, like a GitHub kind of thing, we do not do that today.
Okay. Okay, I think that's covered all of the questions submitted during the webinar. So thank you, Enrico, for answering those questions so eloquently and in such a detailed way. And thank you once again for presenting on our webinar today. Obviously, if you have additional questions, please submit them to MIPI, to our email address. You should be able to see a contact MIPI box in your browser. We do our best to get back to you any questions that are submitted through that to the email address. Otherwise, I think we are done for today's webinar. So thank you, everybody, for attending today. I hope you found the webinar useful. Of course, if you have additional topics, ideas for future webinars, again, please contact us through the admin email address, and we'll do our best to obviously satisfy the demand for additional webinars in the future. So thank you, everybody, for participating today. I'd like to close today's webinar. Thank you. Bye.